Hello, dreamer. I'm so glad you're here. Maybe you've had a long day, or maybe you just love drifting off beneath a sky full of stars. Beneath Tolls tonight, we'll gently explore one of the universe's most mysterious transformations. What happens when a star dies? There's nothing you need to do. Just breathe, get cozy, and let the cosmos carry you towards sleep, one soft thought at a time. There is a moment that almost everyone has felt at least once. A quiet evening, a soft pillow beneath your head, the night sky stretching above you like a great calm ocean of light. You look up at a star. Just one. Maybe it is faint. Maybe it flickers a little through the atmosphere, and in that flicker, a question rises so gently you might almost miss it. How long has that star been shining? How far has its light travelled? And someday, when that shine comes to an end, what happens then? You do not need to move. You do not need to know any equations or complicated ideas. You only need to keep breathing easily, letting curiosity drift through you like a breeze. Because tonight, we are going to stay with that single point of light, not the whole sky, just one star. We will follow its life. We will stay beside it when things begin to change, and we will not look away when it reaches its quiet and magnificent end. Stars are old, older than mountains and oceans, older than every living thing that has ever walked or flown or swum on Earth. Their light travels across impossible distances just so it can reach your eyes for a moment before you fall asleep. It is easy to think they live forever, that they are unchanging, but stars are alive in their own cosmic way. They burn. They breathe in slow nuclear rhythms. They are born. They grow. They change. And yes, eventually, they die. Imagine that one star, our companion for this story. Perhaps it is like the sun, a warm and steady type of star that lives for billions of years. Right now it is healthy. It shines because deep inside it, atoms are fusing together, hydrogen turning into helium in a process that keeps the star bright and in balance. Gravity pulls inward. The heat from fusion pushes outward. It is a perfect calm, a perfect truce. And that truce can last longer than the entire history of human civilization multiplied 1,000 times. For now, our star is safe. Its surface is bright, sending out photons that will wander through space for ages before arriving anywhere at all. If you were drifting close to this star, you would feel warmth on your skin. You would hear nothing, because space holds no sound, but you might feel the silent roar of energy moving past you. It is stable, peaceful. It is doing exactly what it was made to do. But deep inside that shining heart, fuel is changing. Bit by bit, hydrogen becomes scarcer. The star does not notice yet. It has plenty to burn. Still, every flicker of light is a reminder that nothing lasts unchanged. Every star carries within it the conditions of its own future, the seeds of its aging, and eventually the first small signs appear that something is shifting inside the core. Not today, not tomorrow, not for such a long span of time that all of human history would look like a quick dream, but somewhere far ahead, gravity will begin to press harder. The core will begin to heat, the balance will tilt, and that tilt is the very beginning of the end. A beginning so slow and gentle that if you were watching the star every night of your life, you would never see it happen. That is how stars change, not with haste, but with patience carved into light. So here we are now, gazing up at that star from a quiet place. You feel your eyelids growing a little heavier. You breathe in, you breathe out. The question remains glowing softly in your mind. What really happens when a star dies? Does it simply go dark? Does it explode? Does it fade away like a memory? The truth is that there are many ways a star can finish its story. Some endings are quiet, like a candle that burns low until only a tiny ember remains. Others are violent enough to light up a galaxy. Some endings compress matter into states that defy understanding. And some go so far that even light cannot escape the final moment of collapse. But all of that is still ahead of us. We are not leaving this star behind. We will follow it step by step. We will move gently. We will not rush through any transformation. Because when a star dies, the universe is telling one of its most important stories. A story about renewal, about destruction, about beauty too enormous for fear, and about how something can end while giving birth to everything that comes next, even to life, even to us. Tonight, there is nowhere else to be. Just this star. Just the long, slow arc of its existence. Just you, relaxing deeper into your pillow or your mattress or wherever you are resting. Let the darkness around you feel like space. Let the distant sounds of the world become part of the silence between stars. You are here. You are safe. And the universe has time for you. Soon we will drift closer, learning what shines inside a star's heart. We will descend past its glowing layers. We will feel the forces that hold it together, and the ones that will one day pull it apart. And through it all, the light will continue to reach us. Calm, steady, ancient. So for now, look again at that single point of light in your imagination. It has been shining for longer than you can comprehend. It will continue to shine for a long while more. This journey is only beginning. And like all the best journeys, it begins slowly, with wonder, with rest, with a question that makes your mind feel spacious and soft. What happens when a star dies? We are about to find out. Gently, one glowing moment at a time. We linger with that star a little longer, but now our attention drifts inward. If the star is a bright lantern in the night sky, then its interior is the glowing fuel that keeps the lantern alive. From the surface it looks simple, shining, constant, but beneath that surface there is motion, there is tension, there is a quiet fire that never stops. Imagine gently sinking through its outer layers. The light around you becomes intense. The heat grows in a way no human body could survive, yet here in imagination you feel only a soft warmth. A star is a layered world. The outside is a calm shell, but each step deeper, you enter regions where atoms are packed closer and closer, where temperatures soar into numbers our minds can barely grasp, and still you drift, moving toward the heart, where all of the star's life begins. At the center of our star lies a core, not a solid core like Earth, not a molten interior like a volcano. It is something stranger, a sphere of gas so hot and so dense that matter is pushed into an entirely new state. Here, hydrogen atoms are squeezed together until they fuse into helium. That fusion releases energy. Light, heat, a constant stream of radiant force that pushes outward and keeps the star from collapsing under its own weight. Gravity wants everything to fall inward. It presses on the star from every direction. In the core, gravity shows its strength most clearly, attempting to crush the gas into a smaller and smaller space. But fusion pushes back. Every time two atoms slip into one, a burst of energy surges outward. These waves of energy push against gravity's tightening grip, and the result is balance, the very reason this star shines steadily in the sky. Our star has been doing this for billions of years, and it can continue for billions more. The hydrogen in its core provides a deep well of fuel. This is the star's calm and stable phase, its adult life. Everything is in harmony. The heat that rises from the core travels outward slowly, bouncing from particle to particle, taking thousands or even millions of years just to reach the surface before escaping into space as starlight. As you float inside this place, you begin to notice details of the fusion process. Atoms that once drifted freely now lock together into something new. Tiny particles dance, collide, merge. Each event tiny and yet multiplied over unimaginable numbers. These events create all the light that touches the worlds around the star. If there are planets circling it, they rely entirely on this central furnace. Every warm breeze, every drop of liquid water, every stirring of life would trace its energy back to this core. The star does not think about this. It does not know it is keeping its worlds alive. It simply follows the laws of nature, quietly turning hydrogen into the building blocks of future elements. This is the slow alchemy of the universe. A star begins with hydrogen, the simplest atom. Over time, in stars like this one, helium collects. The core becomes richer in it. What is simple becomes complex. And although the star remains bright and calm on the outside, deep within it, everything is changing. Hydrogen is plentiful, but it is not endless. Fusion gradually eats away at it. As the ratio shifts and helium grows more dominant, the star must adjust. The core shrinks a little under gravity and heats up further. The surrounding layers respond to that change, expanding slightly. The star grows brighter very slowly, and yet if you watched from Earth for a lifetime, you would not notice any difference. Time moves differently for stars. Change takes place over eons. Still, the first hints of aging are present here inside the core. The star begins storing helium like a secret it cannot yet use. Helium fusion requires even higher temperatures than hydrogen fusion, and this star is not quite ready. So the helium simply accumulates, forming a dense heart of ash from fusion's earlier fire. Above that core, hydrogen continues to burn in a shell. The star does not fail. It adapts, it stretches, it shifts its rhythms. The calm is still strong, but the seeds of transformation are now unmistakable if you know where to look. Let yourself drift outward again to the middle layers where rising and falling currents of gas carry heat through a slow boiling motion. It is turbulent here, but in a hypnotic way. Great loops of plasma cycle upward, cool slightly, then sink back down again. This endless movement is like the star's breath. It is part of how the internal fire feeds the shining surface. And then back to the outside, where the star radiates everything we see from afar. The surface still looks perfect. You would never guess that its heart is quietly changing, preparing for the next act of its existence. This brightness is the star's promise. Everything is fine. Everything is as it has always been. But now you know there is a story unfolding inside that light, slow as the turning of galaxies. As you gaze once more at the star from the tranquil distance of your imagination, you feel the comfort of its steady glow. It has been shining longer than Earth has existed. It will keep shining long after we are gone. There is no hurry. The processes inside it unfold with patience beyond measure. Yet the truth remains. A star is not eternal. Its life is a long balance between gravity and fusion. When the fusion changes, the balance shifts. One day, the hydrogen will run low enough that the core collapses more noticeably. When that happens, helium will ignite in a sudden rush of new strength. The star will swell, the surface will redden. Everything will become larger, brighter, and more fragile. But not yet. For now, the star glows quietly. The fusion fire hums along in its core. Your breathing stays steady. The night sky remains vast and gentle above you. As we move forward, we will stay close to this star. We will follow what happens when its fuel truly begins to dwindle, when gravity grows impatient, when the heart of the star begins to shift from gentle warmth into something more dramatic. For now, simply hold on to the knowledge that inside every calm star is a slow ticking clock, not a countdown toward darkness, but a path toward transformation, toward the next phase of existence, toward the eventual moment when shining gives way to change and the true adventure of stellar death begins. The star continues to shine, steady and sure, but if we could listen closely enough, if we could feel the deep rhythms inside it, we would notice that the harmony has shifted. Fusion is still strong, light still pours outward in a constant flood, but gravity has begun to speak more loudly than before. The core grows heavier, filled now with helium that cannot yet burn. The star is aging, and the changes within it are gathering like clouds on a peaceful horizon. Inside the core, the last of the hydrogen struggles on, but it is no longer enough to hold gravity fully at bay. The core begins to contract. When gravity squeezes matter tighter, The temperature rises. That heat spreads outward. The regions around the core, where hydrogen remains plentiful, now become hot enough for fusion to ignite there as well. So fusion shifts into a shell around the core, adding new energy in a way the star is not used to. More heat, more light, more pressure pushing outward. The star does what any living thing might do when pressured from within. It expands. Slowly at first, so slowly that nothing seems different across millions of years, but then inevitably the process accelerates. The star swells, stretching into a giant, its edges drifting farther into space. The surface cools as it spreads thin, turning from bright white or yellow into a deeper, softer red. What was once a familiar star becomes something larger, more luminous, more dramatic. This is the red giant phase, the beginning of true transformation. If this star had planets, their skies would change dramatically. A once tiny sun would now loom large overhead, a massive sphere that dominates the horizon. Worlds that once basked in comfortable warmth might now find themselves scorched or swallowed entirely. The system reshapes itself around the star's new size and new appetite for space. Deep inside the giant's expanded form, the core keeps shrinking under gravity's relentless pull. Helium piles up, compressed tighter and tighter, heating more and more. It is like a breath held too long, a tension that demands release. The temperature climbs toward a threshold where helium can finally ignite, fusing into carbon and oxygen. But the moment is unstable and dramatic for stars in this mass range. When helium fusion begins, it does not do so gently. It arrives like a thunderclap made of pure fire. Astronomers call this a helium flash, but in a silent universe where light does all the talking, the flash is more like an interior burst of heat that rearranges everything. For a brief moment, the core blazes with incredible energy. The star contracts slightly as the imbalance shakes itself into a new form. Then a calmer phase begins, with helium now serving as the main fuel. The star draws itself inward a little, finding a temporary balance once again. Yet the time gained is shorter now. Helium burns faster than hydrogen. The countdown continues, even if we cannot see the numbers. As the helium runs low, the star faces another turning point. The core once again fills with ash, this time carbon and oxygen, and again gravity tries to compress it further. In stars like ours, like the one we are following, the temperatures required to fuse carbon will never be reached. The star has used up the only fuels it can truly burn. Its heart becomes a hot, dense weight, unable to push back against gravity in the way it once could. While the core tightens, the outer layers behave differently. They grow unstable, swelling and breathing in long, slow pulses. The star might expand beyond even its earlier giant stage, becoming a red supergiant if it has enough mass, or remaining a glowing, swollen red giant if it is more like the sun. In either case, its outer envelopes are loosely held now, like a blanket slipping from tired shoulders. Great waves of stellar wind begin to blow from the surface. Gas and dust drift outward in gentle clouds, forming a halo around the changing star. This material glimmers under the star's light, a sign that pieces of it are already floating free. What once formed part of the star's very body now becomes stardust, ready to wander the galaxy. This is the stage where the star feels its endings most clearly. It has grown older, larger, and more fragile. Its once steady glow flickers ever so slightly. Its outer layers quiver, almost as though the star is remembering every age it has lived through, and every moment that brought it here. It has burned bright for longer than human minds can hold. But even stars have limits. Let us imagine standing on some distant world watching this transformation. The star that once seemed eternal now fills the sky with a deep red light. Shadows are softer, stretching long across silent landscapes. Nights fade into brief twilight. Perhaps oceans begin to warm too much. Perhaps ice melts. Perhaps life, if it ever existed here, finds the sky too close and the days too bright. The star gives everything it has left, but its gifts grow overwhelming. Yet even now, in this swelling, aging form, there is beauty. A star reaching the end of its fueling is not a failure. It is a transition into something new. It is the moment where creation and destruction weave together. The layers that drift away hold the elements the star has forged over its lifetime. Those elements will one day become part of planets, moons, living cells, iron in the blood of creatures yet to be imagined. Inside the star, tungsten hot and trembling with pressure, the core is becoming what it will eventually remain long after the rest has gone. A tiny, dense object of incredible heat waiting to be uncovered. When the last helium is used up, when fusion can no longer fight gravity at all, the core will reveal itself, and the outer layers, unable to cling any longer, will drift away fully, forming a glowing shell around the shrinking star. We are not there quite yet, but we are close. The star is changing faster than ever before. What was once a tale of billions of years now begins to unfold across shorter stretches of cosmic time. A final shape awaits. You breathe gently, imagining that red giant star pulsing above you, its light warm and mellow, its story almost ready to enter the next stage. Nothing about this feels rushed. Stars end the same way they live, in great sweeps of time, through cycles that feel eternal from where we stand. And yet, the shift in the core is undeniable. Gravity is winning its slow and ancient battle. Soon, the gentle endings will begin. Not explosions, not violence, but a quiet release. We will drift with the star as it sheds the last of itself into space and reveals the small brilliant ember left behind. This is the moment when a star stops growing and begins letting go. The star has reached a fragile beauty. Its once compact surface has swelled outward, turning the sky into a deeper red wherever its light falls. It is enormous now, far larger than it was in youth, yet softer at the edges. Its outer layers cling loosely, drifting like shimmering smoke in slow motion. The balance that once defined its life has tipped. The internal fire no longer keeps up with gravity. And so, piece by piece, the star begins to release what it can no longer hold. Imagine watching from a safe distance. The giant star pulses. With each gentle contraction and expansion, the edges loosen further. Gas escapes into space, carried by slow winds that sweep outward. These winds are not storms as we know them. They are quiet, wide and constant, like a breath too tired to draw itself back in. Fusion in the core has nearly ceased. The helium that once blazed has been mostly consumed, leaving behind a core made of carbon and oxygen. That core, though no longer burning new elements, glows white-hot from the memory of fusion. It contracts under gravity, packing matter tighter than anything on Earth could withstand. And around that shrinking jewel lies an atmosphere that no longer has the strength to stay attached. The outer layers peel away. What remains of the star's energy pushes them outward, forming an expanding bubble of gas that slowly detaches from the fading giant. Over thousands of years, this bubble spreads into space, thinned and stretched until its delicate patterns reveal themselves in beautiful glowing shapes. A cosmic lantern blooming in darkness. Astronomers call it a planetary nebula, not because it has anything to do with planets, but because early observers mistook these soft circular glows for distant worlds. Inside the clearing shell, only the core remains. But that core, compressed and blazing, does not fade right away. It shines fiercely, a tiny spark of incredible density and heat, able to illuminate all the gas drifting away around it. This tiny star is now a white dwarf, the final form for a star like our gentle companion. A white dwarf is small, no larger than Earth, yet holding close to the mass of the entire original star. Gravity inside it is so strong that atoms are crushed into a packed sea of electrons. There is no nuclear fire left to burn. The star does not shine because of energy produced today. It shines because of heat trapped inside, slowly radiating away into space over billions upon billions of years. What does such an ending feel like? Picture yourself floating close to this tiny core. Its light is intense, bright enough to outshine the entire nebula surrounding it. Something once great has been stripped to its simplest form. There is no turmoil now. The violent pulses are over. Fusion is done. The star lies still, a quiet ember. Around it, the nebula glows in soft blues and greens and pinks, shapes sculpted by the star's last breaths. These colours are the star's gift to the surrounding galaxy. Through them, it releases everything it created in its long lifetime: carbon, nitrogen, oxygen. Elements that will someday belong to new stars, to comets and oceans, to the breath of living things. The star has died in one form, but has left behind the ingredients for life. On any worlds that might once have orbited this star, there is silence now. The warmth that sustained them has faded. Perhaps their surfaces are frozen solid. Perhaps their air escaped into space. If life once found a way there, it would now drift only in memory. But the story continues. Because life too is a pattern that finds new paths. What this star has given will not be lost. The white dwarf holds its shape, resisting collapse only because electrons refuse to be squeezed any tighter. It is the smallest star that is still a star, a survivor. Over time it will cool, from white to yellow to red, eventually becoming a dark, invisible object called a black dwarf. But that final dimming is so far in the future that the universe itself is not yet old enough to contain even a single black dwarf. White dwarfs have existed for billions of years, and they will continue to glow for billions more before the last of their heat fades. The nebula will expand outward, thinning into invisibility within a few tens of thousands of years. It will join the interstellar medium, becoming part of the dust and gas that swirl through the galaxy. Like autumn leaves carried by long winds, these clumps of former starlight will drift until gravity finds them again. Nothing here is wasted. The universe reuses everything. We look again at the white dwarf inside its nebular bloom and feel the quiet dignity of this ending. It is not dramatic. It is not destructive. It is a gentle release, a humble goodbye. The star began as a cloud of hydrogen. It burned bright for billions of years. It expanded into a giant of soft red light, and now it rests as a tiny luminous core surrounded by the beauty of its own cast-off skin. A life well lived, a death that gives more than it takes. It is easy to think that this is the conclusion. The star has become its final form. The outward radiance is slowing. The heart is cooling. The story feels finished. But the universe often writes stories across long stretches of time. Every ending belongs to the beginning of something else. The atoms floating outward will find new purpose. The white dwarf will remain as a tiny witness to epochs still to come. And yet this is only one kind of stellar ending. Not every star dies gently. Some hold greater mass. Some build heavier elements. Some wait for a collapse so powerful that it shakes the galaxy around them. Those stars do not drift away quietly. They go out in fire. As you breathe softly, letting the image of the white dwarf and its glowing nebula dissolve into the darkness of your imagination, we begin to turn toward the other path a star may take. A path not of drifting release, but of sudden transformation. Soon we will stand in the heart of a massive star whose ending is nothing like this peaceful one. The light will not fade. It will erupt, and the universe will notice. Now let us turn toward a different fate. Imagine a star much larger than the gentle one we have just accompanied to rest. From the moment such a massive star is born, its destiny is already leaning toward violence. It burns brighter, hotter, faster. Its life is a sprint, not a stroll. Millions of years instead of billions. It spends its fuel lavishly, almost recklessly, as though it knows how little time it truly has. From afar, this star might look similar to any other bright point in the sky, but up close, the differences are dramatic. Its surface is a storm of energy. Its core roars with nuclear reactions pushing against gravity with extraordinary force. It shines with a luminosity that outmatches smaller stars many times over, and yet, That very brilliance is a warning. The hotter the fire, the shorter the burn. Let us descend inside this giant and sense the impatience of its core. Hydrogen fuses into helium rapidly, building up a heart that grows heavier quickly. There is no long, peaceful era here. Once hydrogen runs low, helium begins to burn almost immediately. Carbon forms, then oxygen, then neon, magnesium, silicon. Each new element signals a deeper stage of aging, and each stage goes faster than the one before. What took billions of years in our gentle companion now happens in the cosmic blink of an eye. In the star's center, materials layer like the rings of a tree, but each layer is defined by fire. The innermost region becomes a forge creating iron, the heaviest element that fusion can make without losing energy. And this is where the star meets a limit it cannot cross. Iron does not release energy when fused, it consumes it. And so, when the core becomes iron-rich, the star finds itself in a crisis. Gravity has been waiting for this moment. Without fusion pushing back, the core begins to collapse inward with catastrophic speed. Imagine the entire mass of a star, larger than the Sun, shrinking rapidly into a space no wider than a planet's city. Electrons are crushed into protons, forming neutrons. Temperatures soar beyond anything this star has ever known. The collapse happens so quickly that if you could watch it in real time, you would barely have time to take a single calm breath. Then, almost instantly, the collapse stops. The core becomes rigid with neutron pressure. It refuses to be squeezed further. Everything falling inward rebounds like a hammer striking an unbreakable anvil. That rebound is the beginning of a supernova. In less than a second, shock waves burst outward from the core, slamming into the layers above. But the initial shock alone is not enough. It falters. It slows. For a moment, death seems to pause, and in that pause, something extraordinary happens. Neutrinos. Billions upon billions upon billions of them flood outward from the newborn neutron core. These ghost-like particles almost never interact with matter, even at their greatest numbers. But in this moment, they do. They strike the infalling layers with just enough force to revive the shock, adding that last critical energy needed to turn collapse into explosion. Now the supernova truly begins. The star's outer layers are blasted into space at incredible speeds. Light erupts with such power that for a brief time, this single star can outshine an entire galaxy filled with hundreds of billions of stars. Radiation storms sweep outward. Heavy elements forged in the chaos scatter into the universe. Gold, platinum, uranium. The rarest and most precious materials are born in this moment of destruction. If there were any worlds around this giant star, they no longer exist. The explosion reshapes everything nearby. Gas, dust, debris rush outward in a growing nebular wave. What was once a single shining source becomes a spreading cloud of glittering fragments. At the center of that expanding chaos lies something new, perhaps a neutron star, only the size of a city yet heavier than our sun, spinning rapidly and sending beams of radiation like a lighthouse sweeping cosmic seas. Or perhaps gravity wins even here, pulling the core further inward until nothing can escape it. A black hole, silent and invisible except for the way it bends space itself. But we will leave those endings for later. Just now, we focus on the explosion unfolding around us. If you could watch from a distance safely, you would witness one of the universe's most dramatic performances. Bright tendrils of gas expanding in great arcs. Colors, shaped by different elements, glowing in delicate structures. A shockwave racing through space, stirring clouds light years away, compressing them, perhaps triggering the birth of new stars. This is destruction and creation intertwined so closely that they become the same thing. The violent death of this massive star does not mark a final silence. It marks a beginning for everything its remnants will touch. The carbon we breathe, the calcium in our bones, the iron in our blood, all once belonged to a star that ended in fire like this. We carry within us the ashes of a long-ago supernova. Every heartbeat is powered by a star's farewell. As the star's debris expands, thinning into the darkness, the shock of its final moment softens. The universe settles back into its quiet vastness. But this corner of space has been changed forever. It has been enriched, blessed with metals and minerals that can form new landscapes, oceans, and living beings. We watch the glowing cloud drift, larger each moment. The light pulses and dims over centuries and millennia. Eventually, the remains of this star will blend into the galaxy. One day, gravity may gather its scattered pieces into new worlds. A new sun may rise from its dust. New stories may unfold. This is the power of a star's death. It creates everything that can become anything. And yet, our journey through the endings of stars is not over. We must move inward toward those strange remnants left behind. The tiny, dense corpses of stars too heavy to become white dwarfs. Objects where gravity reshapes matter into forms never seen on Earth. Next, we will drift down to the surface of a neutron star. We will feel the weight of a mountain that could fit in your hand. We will sense matter pressed to its strangest limits. And in that silence, in that extreme form of what remains, we will hear the echo of the star that once was. For now, breathe slowly. Let the glow of the supernova fade into darkness. Let the shattered star dust settle softly in your imagination. This is how some stars end. With brilliance. With thunder made of light. With a final gift scattered lovingly across space. The storm of the supernova has passed. The great cloud of glowing debris drifts outward into the long dark, threads of gas and dust stretching like delicate lace across empty space. The blast has hurled the star's outer layers far away, but something remains at the center, incredibly small compared to what the star once was, a core that refused to break, a remnant carved from pure pressure and unyielding gravity. We drift closer. At first it seems unremarkable, a small sphere no wider than a single earthly city. But as we draw nearer, details sharpen. Its surface is perfectly smooth, flawless in a way no natural mountain or valley could ever be. And the closer we come, the more we feel a silent truth. This object carries nearly the full weight of a massive star. Compressed, concentrated, confined. This is a neutron star. Matter here has been forced into a nearly impossible form. Protons and electrons crushed together become neutrons. Atoms that once had space between their particles now pack tight like stones in a wall with not even the tiniest gap remaining. If you could scoop up a spoonful of this material, even a raindrop of it, that droplet would outweigh mountains back on Earth. Billions of tons in the space of a bead of water. Gravity is intense here, beyond measure. If you were somehow able to stand upon the surface of a neutron star, you would feel weight so overwhelming that your feet would sink and flatten before the thought fully formed in your mind. Space and time themselves bend under the strain. Light curves downward, trapped near the shining surface until forced outward only by sheer momentum. And yet, strangely, this dead star core is full of motion. It spins. A neutron star created by a collapsing massive star continues to rotate, but what was once a turning sphere the size of a sun now rotates as a sphere the size of a city. Angular momentum is a tireless law. The smaller the object becomes, the faster it spins. Many neutron stars rotate dozens of times a second, some hundreds. A few turn faster still, ticking space like a heartbeat you can almost feel, though it lies dozens or thousands of light years away. With that spin comes something else, a magnetic field so strong no compass could ever stand against it. It traps charged particles and forces them into beams that shoot from the poles of the neutron star like lighthouses of pure energy. If these beams sweep across Earth, we see pulses of radio waves or light blinking at perfectly precise intervals. A celestial clock. We call such a neutron star a pulsar. Imagine hovering at a safe distance, watching those beams flash like the slow blink of some cosmic eye. Each rotation is constant, predictable. The pulses can be timed down to fractions of a millisecond. It is as though the star's dying breath has become a metronome, keeping time long after the music of fusion has ended. Inside, things are stranger still. The matter in a neutron star may not behave like any substance we know. It might be a superfluid, frictionless and perfectly smooth, with currents that flow forever without slowing. There might even be an core where quarks, the tiniest building blocks of protons and neutrons, float free in a soup beyond our wildest theories. Scientists on Earth can only guess. We cannot examine such matter directly. It is too dense to bring home, too extreme to recreate. And yet, from the peace of your imagination, you can drift just above the surface, sensing the weight of everything here. This is what remains when a star refuses to surrender its core to empty space. It is the middle ground between survival and disappearance, a compromise between gravity and the last resistance of matter itself. There is no fire left to burn, no new light being made. The glow we see is the leftover heat of a stellar heart that once forged elements in violent bursts of fusion. Over millions of years that heat will dim, the pulsar beams will slow, the rotation will lose momentum, and the neutron star will eventually become dark and cold, a silent monument to what the star once was. But even this may not be the final word. Some neutron stars find companions. A nearby star might drift too close. Gas might fall from one body to the other, spiraling around the neutron star in a bright disk of hot swirling material. As the neutron star feeds, it grows heavier, and if it becomes too heavy, too massive, too overwhelmed by its own weight, there is only one future left. A tipping point. Gravity wins. Even neutrons cannot hold the collapse back. The surface folds inward, space itself buckles, a final threshold is crossed, where mass becomes so concentrated that nothing, not even light, can escape. The star disappears not by fading, but by falling inward past the point of return. A black hole. But that is still ahead of us. In this moment, the neutron star remains, humming softly with rotational grace, a compressed jewel of gravity in the dark. It is both an ending and a continuation, a reminder that the universe knows how to hold onto its creations, reshaping them, preserving some essence even as others are scattered into dust. Look one more time at this tiny star core. Feel how calm it seems despite its impossible nature. Stars can end quietly, like the white dwarf we saw before, or they can end in thunder and become this, a remnant so intense it nearly breaks our imagination. Breathe slowly. The story of stellar death continues deeper still, into the places where even neutron stars cannot survive. We will soon cross that threshold. We will follow the collapse all the way inward. We will stand at the edge of where time slows to a crawl, and we will face the most mysterious ending a star can have. But for now, rest in this awe. A sun has died, and left behind a spinning diamond of gravity that will outlast the worlds that once might have circled it. We leave the neutron star behind, drifting outward into cooler space, but not for long. Another star calls to us, a star even more massive, one that burns brighter, lives faster, and dies with a force nothing can resist. For such a star, the collapse that creates a neutron star is not the end. There is still too much weight, too much mass pressing inward for matter to withstand. And so, we return once more to the violence of a core imploding. Inside this star, iron has built up the same way it did in the previous giant, but here, the star is too heavy for even an iron core to hold itself together. The moment fusion stops supporting the structure, gravity seizes control, fierce and unstoppable. The core collapses, but this time the rebound is not strong enough to halt the descent. Neutrons themselves buckle under the pressure. The collapse continues. Downward, inward, toward a point of unimaginable density. Space folds. Light warps. Time begins to behave strangely. The collapsing matter shrinks to a region so small that our minds cannot picture it, and when the core shrinks past a certain radius, an invisible boundary forms around it. This is the event horizon. A silent border where the rules change. Inside, no path leads outward, not for matter, not for radiation, not even for light. The fastest traveler in the universe, anything that crosses this boundary cannot return or communicate a single detail of what it experiences. A black hole has been born. From a distance, there is nothing visually alarming about it. Not a glowing monster or a swirling cosmic whirlpool, just a dark patch surrounded by chaos. But if you look closely, you see a strange halo, like a ring of fire. That glow is not the black hole. It is the last desperate light of matter falling inward, heated to incredible temperatures as it spirals toward oblivion. We hover safely far away, close enough to observe but not cross the threshold. The black hole's gravity is vast. It bends starlight around itself, creating an eerie lensing effect. Background stars appear stretched, distorted, doubled. Space itself seems to curve like fabric pulled tightly downward. If we released a beam of light directly upward from this region, it would not travel straight. It would bend inward and fall back. The escape velocity here exceeds the speed of light, and since nothing can go faster than light, nothing escapes. Not even information. Not even time. Imagine the last moment of a star's light touching your eyes, then slipping inward and vanishing forever. It feels like a whisper being swallowed by silence. The black hole appears still, but it is full of motion. Matter that falls too fast forms an accretion disk, swirling at speeds that would tear anything familiar apart. Particles collide, radiating energy that can outshine entire galaxies. In some cases, magnetic forces twist these flows and fire narrow jets of plasma outward, shooting into space at nearly the speed of light. These jets can extend for thousands of light years, like giant beams marking the location of a silent, invisible heart. The event horizon is the calm surface of a deeper storm. Inside, physics becomes strange. Space and time seem to trade duties. Falling inward becomes as inevitable as the passage of time itself. There are no stable orbits within, no pauses, no escape routes. All motion leads toward the center. The center is called the singularity, a point where density becomes infinite, where the known laws of physics stop being able to describe what is happening, where the story slips away from us. No one knows what truly lies inside a black hole. A collapsed star, a doorway, a seed of a new universe forming in isolation. The theories stretch wide, but the event horizon keeps its secrets perfectly. The black hole is not a hungry force actively pulling everything around it. It simply exists as gravity itself in its deepest expression. If the sun were replaced by a black hole of equal mass, Earth would continue its orbit unchanged. It would remain dark and cold, but our motion through space would be the same. Gravity does not become monstrous, it simply becomes efficient. Stars die into black holes when they have given everything they had. They shine for as long as they can. They explode when they must. Then they collapse inward, leaving behind a shape defined only by mass, spin, and electric charge. Personality stripped away, history hidden. A star's entire life turned into a silent well of gravity. And yet, the influence of a black hole reaches far beyond its lost light. The galaxy itself responds to its presence. Stars drift in wide arcs around the invisible mass. Gas and dust feel its tug and spiral inward. New cycles begin, shaped by the leftover footprint of a death that changed the geometry of space. Eventually, even a black hole will fade through Hawking radiation, leaking energy so slowly that the process would take longer than the universe has currently existed. A star's death can unfold across eons beyond measure. For now we hover in quiet admiration, a place where light gives up, a place where time slows to a crawl, a place where a star that once illuminated its surroundings now holds darkness so deep it becomes its own kind of wonder. Take a slow breath. We have witnessed endings gentle and endings violent, but the story of a star's death does not conclude with disappearance. Even a black hole's silence sends ripples through the cosmos. What remains continues to shape what comes next. Ahead of us lies the aftermath, the echoes, the remnants, the rebirths. We will follow those next. Because a star's death is not just a conclusion, it is an entire chapter of the universe's endless cycle of transformation. And in that cycle, you will find a connection deeper than you might expect. The black hole remains behind us, holding space and silence in its invisible grip. Around it, the universe grows quiet once more. The brightest moments of a star's death have faded, leaving echoes instead of fire. But echoes in the universe are never truly still. They ripple, they reshape, they become the building blocks for what follows. Let us drift gently out into the expanding debris of a supernova. The cloud of dust and glowing gas is far larger now than when the star first burst apart. If we could measure its growth, we would see it stretch across light years, a wave of memory spreading outward in slow, eternal confidence. This shock wave continues to push into the interstellar medium, compressing and heating the gas it encounters, and in that compression lies possibility. The debris of a star is rich with new elements: oxygen, carbon, iron, even those rare metals like gold. Scattered into space by the explosion, these atoms now float freely for the first time. Everything that once lay locked deep within the star's core is released, like seeds cast across a field waiting for the next cycle of growth. We watch as some portions of this expanding cloud cool and thicken. They twirl into knots, filaments form, dust clumps around grains as small as smoke. The star's remains begin to gather quietly into fresh structures. Gravity, patient as always, begins to weave again, pulling the scattered pieces into shapes that might one day glow with new life. Even the shock waves themselves leave their imprint on the universe. They create ripples not only in gas and dust, but also in the very fabric of space-time. These ripples are gravitational waves, faint shudders that travel across the cosmos at the speed of light. We can detect some of them now, tiny compressions and stretches in space caused by colossal events long ago. A reminder that when stars die, the universe listens for millions or billions of years afterward. Farther from the chaos lies a quieter relic, the nebula shell left behind by smaller stars like our earlier companion. These shells form intricate patterns, shaped by gentle winds and ultraviolet radiation from the glowing white dwarf within. Each one a piece of cosmic art, lasting only a moment by galactic standards before drifting apart. Some remnants merge together, some pass each other without touching, others collide head-on, creating mighty bursts of radio waves or new supernovae. The universe is wide and without hurry, but motion is constant, and every motion shapes what might come next. In some regions, the scattered metals find their way into cold molecular clouds. These clouds are the dark wombs of the galaxy, places where starlight cannot penetrate. Inside, dust and gas gather densely, and gravity, ever watchful, waits for a chance to begin anew. A slight disturbance is enough to trigger collapse, a passing shockwave from a nearby exploding star, or the simple tug of a neighboring cloud. Slowly, quietly, a new star will form. Dust will spiral inward, gas will heat up, fusion will begin again inside a bright new core. And planets may form in the leftover debris, rings of rock and ice, circling the infant star like dancers around a flame. Already we see how endings become beginnings. The death of one star can spark the birth of many others. The galaxy is a tapestry woven of these transitions. Each explosion adds color. Each collapse adds structure. Each remnant becomes a thread in something larger. Imagine looking at a spiral galaxy from far above, seeing its arms stretching outward in sweeping curves. Every bright knot in those arms is a cradle of new stars, ignited by the shock of older stars dying. Every dim shadow between the arms holds the cold, waiting clouds of the future. a constant cycle of light emerging from darkness, darkness gathering strength to become light. And in the center of galaxies, massive black holes gather the motions of billions of stars into slow, graceful spirals. They do not merely end a star's life, they help shape the architecture of everything nearby. Even the most mysterious remnant plays a part in creation. We float within the cloud of a star's forgotten body, and around us, gravity draws creative lines like a sculptor. What once was heat and fire now becomes clay waiting to be molded. Worlds will form here, oceans will rise, alien skies may someday be reflected in liquid surfaces made of elements forged by this very star. Everything changes, nothing vanishes. A dying star scatters its story across the universe, allowing countless new stories to begin. A white dwarf cools slowly in the dark. A neutron star spins with a steady pulse. A black hole waits at the center of an invisible whirlpool of light. And everywhere, dust born from stellar death falls into new shapes. These remnants are quiet reminders that nothing in the cosmos is wasted. Even endings are generous. As we drift further outward, the light grows fainter and the dust thins. Our understanding grows clearer. This cycle of collapse and renewal is how the universe evolves. Every star that dies reshapes what the future may look like. If no stars ever ended, no new stars would ever be born. There would be no planets, no landscapes, no chemistry of life. No us. We are part of this aftermath too. The iron in your blood did not originate on Earth. The calcium in your bones once lay in the heart of a giant star. The oxygen you breathe was formed in quiet fusion. The carbon that shapes your thoughts, your muscles, and your dreams came from stars like these exploding long before Earth existed. You too are a remnant of a cosmic death. A story continued, a spark carried onward. Softly now, we recognize that the death of stars writes the story of the universe. It fills the dark with potential. It gives the future room to grow wings, and it ensures that light never vanishes. It just changes shape. The echoes of what these stars were will linger far longer than memory. They will drift. They will gather. They will ignite again. And our journey is not finished. There is another transformation ahead. We will follow the dust as it finds purpose. We will watch new worlds form from the ashes. And we will stand on the shores of what was once a dying star, seeing a sunrise begin anew. We move gently now, drifting with the slow current of starlight into the deep future. The supernova's glow fades behind us, but the dust it released has begun its own quiet work. Across the galaxy, fragments of stars gather, forming clouds thick with the raw materials for creation. The cycle continues toward rebirth. Within one such cloud, a tiny region darkens, as if space itself is taking a deep breath. Gravity has found a home here, and it begins to pull the gas inward. Molecules collide more and more frequently. Heat rises in the heart of this gathering mass. What was once only a whisper of possibility becomes pressure, density, and structure. This is how a new star begins, not in roaring fire, but in darkness. We hover as the contracting cloud twists into a rotating disk. Dust within it glitters like embers waiting for a spark. A warm glow builds at the center, faint at first, like the pulse of an unborn heart. As the heat increases, hydrogen atoms tremble and fuse, releasing energy for the first time. Light bursts forth, gentle and soft at the beginning, but growing stronger with every moment. A star has been reborn, forged from the remains of another. What once was a violent ending has become a quiet beginning. But the story doesn't stop at the star. The leftover dust in the spinning disk clumps into grains, grains into stones, stones into mountains. They collide, merge, break, and merge again. Some become planets, some remain asteroids, some become frozen travelers in the far edges of the system. If you could reach out and hold a pebble from one of these newborn worlds, you would hold in your palm the ashes of a star that died long ago. The iron within it, once belonged to a heart of fusion. The silicon came from the shock of a supernova. The carbon once surged through the veins of a living sun. Every solid world is a graveyard of stars. Every living world is a second chance. We drift closer to one particular planet forming near the warmth of the star. At first it is molten, glowing with internal heat. Volcanoes roar, seas of lava bubble, and meteor storms carve vast scars across its surface. But time is patient. Cooling begins. The molten oceans harden into crust. The world breathes out steam that becomes rainfall. Lightning cracks the early sky, energy mixing elements into complex shapes. In such places, life may stir. Life is a delicate continuation of stellar fire. In every leaf, every cell, every spark of thought, there is a little of that ancient starlight. The universe builds living memory from dead suns. We step back and watch the larger picture unfold. Across the galaxy, millions of stars are dying every year, and millions more are being born. The spiral arms shimmer with youth and age at once, bright nurseries beside exhausted remnants. The center glows with dense crowds of old giants, their long fates written in the patterns of light. The entire galaxy is a cycle in motion, a great wheel turning so slowly we can only see its transformation across epochs. But from here, drifting weightlessly, we see how elegantly it all connects. The universe does not favor beginnings over endings or endings over beginnings. It simply moves, endlessly. Even black holes, those most mysterious of endings, can guide new stars into being. Their gravity shapes the flow of gas. Their jets stir materials into motion. Their presence anchors entire galaxies, giving them coherence, identity, and form. The death of a star seeds the birth of a system. The birth of a system may one day nurture minds capable of wondering where they came from. And those minds will gaze upward, recognizing faintly that they belong to something older than memory, older than worlds. Perhaps they too will tell stories of how stars die and how stars are born. We look at our own distant sun, burning quietly in a corner of the Milky Way. Its future is already written. It will one day swell into a giant red blossom, shed its petals into space, and leave behind a white dwarf that will shimmer long into the night. And the particles that once formed Earth will find new homes, drifting onward into whatever comes next. Our world, like all worlds, is a temporary arrangement of ancient dust. But temporary does not mean unimportant. Every rearrangement of stardust holds potential. Every cycle sparkles with new meaning. You, sitting here now, are proof. The universe is not a place of waste. It is a place of transformation. It takes endings and makes beginnings. It takes silence and makes sound. It takes darkness and makes light. And even when the light goes out, the darkness begins to weave a new story. We are nearing the end of this journey, but not the end of the stars. The cycle will continue long after worlds like ours sleep. There will come a time when the last star burns out, but even then, something quiet and beautiful will unfold, as the leftover heat of the cosmos cools into a final peace. We will visit that future soon. For now, take a breath and feel this truth settle softly inside you. A star's death is never just an ending. It is a promise that the universe keeps endlessly. We drift now into a distant future, far beyond the rising and falling of individual stars, far beyond the birth of worlds. The galaxy still glows, but not as fiercely as before. Star formation slows, because the gas and dust needed to ignite young suns has become scarce. The great spiral arms shine with older populations. The bright nurseries fade. And yet, stars continue to die, each death adding more elements to the cosmic inventory, each explosion scattering new possibilities. The cycle persists, but at a gentler pace. Millions, then billions, then trillions of years pass. Red dwarfs, the slowest burners of all stars, continue their quiet vigil, while massive stars have come and gone in brilliant fireworks. These tiny embers cling to existence. Some red dwarfs may live 1,000 times longer than the universe has currently existed. Their glow is faint, but persistent, like the last candle burning in a vast cathedral. Planets around them remain cast in dim light, perhaps nurturing strange life adapted to twilight. If any beings there look up, they might never know a bright daytime sky. Their suns never needed to roar. They hum softly across the ages. Eventually, even these durable stars begin to fade. They swell slightly, shed thin layers of gas, and their fusion slows to almost nothing. The glimmer that once warmed their worlds dims into near darkness. The universe enters a new era. Black dwarfs remain where white dwarfs once glowed. No longer warm, no longer radiant, just cold spheres of carbon and oxygen, drifting like forgotten marbles across an expanding sea. Neutron stars hold onto their hidden gravity. Black holes endure longer still, swallowing stray matter with patience bordering on eternity. But nothing lasts untouched. Over unimaginable timescales, even black holes slowly evaporate through Hawking radiation. They shrink, they fade, they give back the energy they once trapped. And then, one day, they will be gone too. The universe grows wider and colder with each passing eon. Galaxies slip so far apart that their light can no longer cross the gulfs between them. The cosmic microwave background cools toward absolute zero. Motion slows. Sound becomes meaningless. Darkness reaches places where light once reigned. It is easy to feel sorrow at this vision. A universe that ends not with destruction, but with quiet exhaustion. A gentle settling of everything into silence. But let us remain here a moment longer and see what peace lies in this stillness. Because this is not a tragedy. This is the fulfillment of a long journey. The universe has spent its life transforming energy into structure, structure into stars, stars into elements, elements into life, life into memory and thought and wonder. You are part of that wonder. Every star that burned contributed to this moment. Every supernova seeded the future. Every collapse carved new shapes into the dark. The universe did not rush to its end. It blossomed, created, and allowed time to unfold more stories than any single being could comprehend. Even the final quiet is a kind of beauty. The long exhale after a symphony's last note. We have watched stars ignite. We have watched them shine. We have watched them die. And now we have followed their legacy into the farthest reaches of time. Through it all, there is one truth that never faded. Endings are another form of transformation. Death is a doorway. Darkness is not empty. Silence is not absence. It is what waits to become something new. The universe may fall into a peaceful sleep, but every moment that came before remains imprinted on the fabric of what once was. Nothing beautiful is ever lost. It merely changes shape. Take a breath. Feel how vast this story is, and remember that you carry a piece of it within you. The stars died so you could exist to witness their story. You are still here, floating gently in the dark, not alone, not lost, cradled by the same universe that once blazed with 1 trillion suns. The journey has slowed now, as if the cosmos itself has settled into a calm rhythm, allowing you to rest along with it. It is quiet. The kind of quiet that holds a warm remaining glow of memory, a quiet that feels like being wrapped in a soft blanket, safe and unhurried. Let the images of distant stars fade slowly from your mind, like embers settling into ash. Let the thoughts soften. You do not need to hold on to any of it tightly. It will all be here when you return. Feel your breathing steady. Feel your body sink a little deeper into comfort. The universe is vast, but you are exactly where you need to be within it. You are made of the same stardust we just watched, drift and gather and burn and rest. You belong to the same cycle, the same beauty. As you drift now toward sleep, imagine a single star burning softly, far away. Its light was born long before you existed, and yet you see it now. The universe waited for you to look up, to notice, to wonder. That alone is enough. Tonight, Let your thoughts scatter like starlight. Let them drift where they choose. There is nothing left to do. The cosmos knows how to continue without effort. Close your eyes when you are ready. Let sleep arrive gently, like a sunrise on the quietest world. And carry with you the comfort that every ending in the universe is just the beginning of something else. Good night,